Hello, everyone, and welcome back to the channel. I'm Juarez, keeping the automation running for Mexico. Today, we are talking our industrial simulation to a next level. We are going to establish a PLC to PLC communication using the L7 pod instruction in Siemens TIA Portal, but we want to stop there. We will control and monitor this entry master slave network remotely using a custom SCADA dashboard in LabVIEW. Let's dive in TIA Portal. Let's start in TIA Portal with our master controller. The master controller is a PLC2. Is this my variable? The communication into PLC 2 and 1 is this commando LED 1 y commando LED 2. The variables in variables PLC is tag 1, 2, 3, aviso LabVIEW 1. The direction is M1.0, aviso LabVIEW 2, M1.1, and the pulse of clock byte 10 Hz, 5 Hz, y encender L1 is LED 1, M0.0, and encender LED 2 is this, M0.1. The main block is this, PLC2. Instead of turning a physical output directly, PC2 acts or communication hub in our main OP1 block. We take the memory bit triggered by our LabVIEW HMI, like encender L1 and encender L2, and we move those states into data block called buzón envío, this, or send mailbox. Once a data packet in the data block, we use the L7 paths instruction. This block is configured to write or send mailbox data directly into memory of a remote partner PLC1 over the network. And the slave is this PLC1. The variable is this, and bloque de sistema en buzón recepción. Now let's look at PLC1 or slave controller, because the put instruction pushes data automatically. PLC1 doesn't need a get block. We simply create a receiving data block called buzón reception. Is this? In the ladder logic for PLC1, we read the incoming Boolean values for the receiving mailbox and use them to organize the physical outputs, turning or receive LEDs. And this is the communication. Only is this in segment 4. And now to link this, the communication A net to PLC sim and OPC server is this. The network address is 192.168.0.100. Only this is the IP address to a PLC2. In this moment is running, and in your PC server, this is PLC2, and this is quit client. My variables is good all. Um, to link this to our SCADA system, we use NetToPLCsim. Notice that we are pointing our network address to the EP or PLC2 because our HMI only need to talk to the master. Then in MPC server, we map all Boolean control tag so LabVIEW can access the uncharted variable. And finally, let's see the full system in action inside LabVIEW. I designed the futuristic I-Touch SCADA interface for this practice. On the block diagram or switches, write data on the UPC tags. This is the tags. And our let's indicator read the feedback. When I sleep switch 1 on the front panel, LabVIEW send the signal to PLC2, and PLC2 packs the signal into data block and uses the put instruction to send into PLC1. Finally, PLC1 turn on your physical LED output. All of this happen in a fraction of the second, demonstrating a perfect real-time industrial network. For example, mhm, let me see, check, encender L1 and encender LED2. In PLC1 is now running the LED1, for example, another, and everything is okay. And there you have a full functionality PLC to PLC network controlled by a central SCADA system. I hope this tutorial helped to understand the power of the ES7 put instruction and how to integrate multiple controllers with LabVIEW. If you have any question about the data block, the network configuration, or SCADA design, please leave me a comment down below and I will be happy to help you out. If you found value in this video, please don't forget to hit the like button and subscribe to channel. As always, I'm Juarez, keeping the automation running for Mexico. Thank you so much for watching, and I see you in the next video. Bye.